I'm Vijay Karamcheti. I'm the Chief Technology Officer at Virident. Thank you for the opportunity to present to you folks today. I guess an oft-repeated phrase in this industry is that flash changes everything. But you might be led to believe by the talks you have heard so far that really when they say everything, it means everything inside the network storage box. So we take a slightly more inclusive view of this, and kind of, that's kind of the background. So in the time that I have, I'm going to start off by talking about the founding vision for the company, where we are at, and the vision that we want to be part of as we move forward. So, page down. This is a Mac. All right. So our vision is to kind of deliver the best-in-class solid-state storage solutions. And as I said, we take a very inclusive view of this. So we've defined something called a storage class memory architecture for non-volatile memory device integration into servers, which I'll spend the next few slides talking about in a little bit more detail. As a company, we've been around since 2006, roughly about 120 people in 2 locations. And over time, we've built up a significant amount of expertise in what we refer to as system-level flash management, and I distinguish it from media level or at the box level. And I think what kind of distinguishes us from some of the folks in the other vendors that you'll be talking to and hearing about from is that our experience has been built over multiple non-volatile memory types and across multiple process generations. And in some sense, that gives us, both it gives us more scars on our back, as well as gives us certain unique abilities that we are harvesting in our products. We are a venture-backed company. So our investors include Sequoia, Globespan, and Arteman. And we also have, some strategic investments from Intel and Cisco, and then they play into the strategy that we are embarking upon. So I mentioned storage class memory. And what is our definition of storage class memory? And I'm taking a graphic that looks as if it is centered on a server, but really the concepts that I'm talking about go beyond a single server at the entire data center level. And really the way we look at the role that non-volatile memory plays in either a server platform or at the data center level is in bridging the gap between the memory and the storage resources one traditionally has access to. So if one takes a look at a server platform, one has access to DRAM resources at one end and traditional disk and capacity resources at the other end. And really the gap between these two in terms of performance, in terms of capacity, in terms of persistence is really where different types of non-volatile memory can plug in. And if you take, from our point of view, this is really more a continuum with different solutions occupying different points in the spectrum, all the way from memory class, storage class memory at one end to traditional disk class, storage class memory at the other end. And PCIe SSDs, by virtue of the design trade-offs and the design optimizations people put into place, essentially occupy some place in the middle in the spectrum. They offer certain properties of memory class SCM and certain properties of storage class SCM. So what are the attributes that are of interest? And I think it's interesting to hear the speakers that have come before me talk about how IOPS is super critical, how latency is super critical, how you really should be focused on IOPS per gigabyte, etc. And I kind of wanted to introduce another dimension or set of dimensions into the mix as you think about how people tend to think about non-volatile memory and what value it brings in the overall data center architecture. The attributes that typically one wants from their memory and storage hierarchy tends to be a mix of capacity, performance, read or write, and persistence. And if you look at the way applications have kind of reacted to the options that have been there, is they have made very conscious choices on how they use each layer of the hierarchy. The kinds of operations that you do against memory structures, that are resident in DRAM tend to be very different than the types of operations that you do against structures that you put in your disks and potentially network storage. So random access is one ability, pointer-based access, things of that kind. These are what distinguishes the different options that are present. And to kind of, expand on the point that I made earlier, that when one considers the role that non-volatile memory technologies play in both the server platform as well as largely in the data center, They allow you to come up with alternatives or plug the gap between DRAM and traditional disks by, in different, ways. So they offer you the capacity of a disk, they offer you the performance of a DRAM, but equally importantly, they introduce a new concept, and the new concept is one of persistent memory. So it is almost as if you could do DRAM-like operations, but with the persistence and the capacity and the cost structure potentially of a disk, and that leads to fairly interesting, kinds of opportunities. And really what the table at the bottom here on the slide is showing is that there are enough technologies that are out there today as well as likely to become available in the near future that give you multiple options, and really it is in this broader space that Virident is playing in. Specifically, our focus is on PCIe SSDs and memory class SCM solutions that are integrated into the server platform. And it's not just about hardware integration and the opportunities that are present there. When we look at storage class memory, we actually take a system level view of this. And on the extreme left of the slide is a very traditional stacking, all the way from hardware to operating systems to applications. And by the time the story is written and is described to your grandchildren, very likely what we will see is that the way people have interfaced with non-volatile memory solutions spans the entire stack. Everywhere from how you attach it at the hardware level to how you interface with it at the operating system level, how your file systems interface with non-volatile memory, to even how applications react to the fact that this new level of storage is being present. And clearly, the fewest things that you disturb guarantees immediate applicability. People want to deploy you immediately because it's very difficult to try and convince somebody that if you're changing 4 things in the stack, there is value. But as technologies become more mature, as people become more comfortable with the value such technologies bring, one is likely to see higher and higher levels of integration across the entire stack. Again, in this broader picture, the space that Virident occupies is one that's focused on performance SSDs today, moving to fully integrated SCM in the future, where we are not treating it as a constraint that it has to plug into existing interfaces. It has to present a storage view of the world, and we actually want to be a part of the effort to try and move people to try and interface with this class of storage and this class of memory in the ways that are most suitable for the value that they bring. So with that background, the product that we have in the market today is a PCIe SSD flash device. We call it Flash Max, and it is server-side solid-state storage. As some of the speakers have talked about, PCIe SSD brings the value of latency. We have a custom software stack by which applications and operating systems can interface with our device that cuts through most of the overheads that are associated with a traditional storage stack. As one of the earlier speakers, I guess Tom mentioned, PCIe SSD is doomed to become commodity, so I feel kind of compelled to tell you how we are different and why we feel there's a lot of room from now to till it becomes commodity. So the key differentiators compared to the other offerings that are already in the market or are the ones that are beginning to make their presence felt are, if I had to kind of summarize it, there would be 3. One is that our solutions are designed for application performance. They embrace this vision that we started off with, which is non-volatile memory is more than a faster disk or a slower memory. It is unique in its own right. People and applications migrate to such storage because of certain unmet needs in existing storage alternatives, and you have to cater to those needs in the best possible fashion. And those are the insights that we have internalized in providing the solutions that we do. So, following up on Jonathan's mantra of steady, predictable performance, low latency, that's really been our pitch as well, and that's really what we have designed for. So our focus is on steady, predictable performance versus peak performance. We are not that enamored with the hero numbers where, once in a blue moon, you will hit certain targets. It is what can you sustain over extensive periods of time as the device is filled to capacity in the presence of mixed workloads. We offer the highest capacity in a low-profile form factor. Our SLC solutions range up to 800 gigabytes. This is in the previous generation, and our MLC solutions range up to 1.4 terabytes. And later this year, we'll be launching the next generation version of this product, which will double these capacities. We offer enterprise class reliability. Clearly, this media has a lot of things going for it. It also has a lot of challenges that one has to deal with when one offers a solution in the enterprise space. And we do through a combination of hardware and software techniques. So when I talk about predictable performance, this is usually the graphic that I use. People usually start off by speccing really phenomenal numbers, saying like, once you have this card, you really don't need anything else. All your storage can be kind of put to rest. However, the reality tends to be very different. Once you start mixing workload, once background flash operations, etc., start playing into the mix. And really, what the graphic shows, this drop in performance, the fluctuations in performance, the spikes, is not very atypical of what people have encountered over the years with flash-based storage. And you have heard the same thing being stated in different ways by the earlier speakers. And really, our target has been to kind of offer steady performance over the entire mix, over the mix of workloads as the card gets filled up. And to some extent, we have kind of met it. But the point that I wanted to make here, when we differentiate ourselves from the other solutions that are out there in the market, is we don't stop by offering steady, predictable performance at the level of throughput. Really, our focus is on the next level of quality of service metrics that is associated with performance. So for instance, what is the jitter over time? Now, the tight band in green is really ours. The red band with fluctuations all over the space, and this is really throughput over or IOPS over time kind of a chart. The variation, the red dots on the bottom are a leading PCIe SSD vendor in the space, and I just kind of wanted to contrast, what is it that we focus on, what is it that we are able to deliver. Another related metric, and again, Jonathan kind of nicely prefaced this for me, is how does the latency of the device vary as you pump more load into it? And really what this graphic is showing is how does the latency vary with IOPS, right? And again, the two, the solid bars at the bottom are ours, for read and write latencies, and as you can see that we hold, fairly stable latencies for a much larger range of IOPS compared to, certain other leading vendors in the space. But, micro benchmarks and talking about predictable performance is only one aspect of things. Really what we are focused on is how do you take the value that the card offers at the micro benchmark level and propagate it all the way to the applications. So really, by virtue of being direct attached to the server level, and what we focus on is what is the value that we deliver at the full application level. The applications that we run in typically tend to be databases, virtualization, checkpointing, high-frequency trading. And across the board, as opposed to doing super well on one application and super bad on the other, what we strive for is delivering constant, steady, high performance across the range of applications. And again, here the green bars are really where we tend to be. And hopefully that gives you a sense of what it is that we focus on in the design of this PCIe SSD product. So with that introduction, really I kind of wanted to spend the remaining 3 minutes or so talking about what our vision for storage class memory in the data center is as we move forward. And this is a typical data center view, compute servers, there's some storage, there's a storage service at the other end and storage networking in the middle. And really the question that you'll hear being asked in many different ways with many different positions taken today is, where does flash or storage class memory fit in this overall architecture? And the answer is probably everywhere, and it offers kind of different values there. But the bet that Virident is making, and really our vision, is that the right place for the integration of this class of storage and this class of solutions is at the server and rack level, as close to the applications as possible, where the unique performance advantages and ultimately the performance is the largest driver for non-volatile memory storage deployment in the enterprise can fit. So the way we see the vision unfolding is that non-volatile memory and storage class memory in general will define its own tier, right? It'll be a server rack level tier that will be made up potentially of multiple types of NVM. It's not the cheapest one that Apple buys for its iPads and iPhones only. It'll include multiple of these. This tier will be accessed using standard APIs, but these are not APIs that are necessarily the ones we are used to today, right? Because SCM offers unique capabilities. It's a persistent memory, it has random access, it supports random writes at significantly higher performance level than everything else. New APIs will emerge for folks to interface with this class of storage. These APIs do need to be standard, otherwise nobody is going to be using them at the application level, but that's really the vision that we kind of want to make happen. These APIs will match the application characteristics to the unique value this tier of storage brings. And ultimately, these will not remain an island in a server, which has been kind of a ding that people have done about direct attached storage, and that has triggered the migration to network attached storage solutions. The vision that Virident is embarking on is how does one support rack level resource sharing, protection, and management for these directly attached, tightly coupled storage elements. And a key driver for us is how does one make this happen without compromising the core value of this tier, which tends to be performance. So you don't want to put it at the other end of a network connection where even though your media is capable of a 50 microsecond access, you go and add 300 microseconds in front of it. And so with that, thank you for your attention. I'm happy to follow up on any of these topics in the panel discussions in the evening. Thank you.